Number 1. These are all exponential rules of exponents. So in each step, what I'll do is I'll just tell you what I see. As long as you get the answer, there's many different ways that you can handle these. So what I'm going to do is I see those parentheses here, and I'm going to tackle those first. So I'm going to have to write small here. So let's go ahead and give that negative 3 exponent to the 2 and to the x. So by giving it to the x, that'll become negative 9. All right, and then there's no changes here. Okay. So now in the next move, what I will do is I will move anything with a negative exponent down to the denominator. Okay. So what that'll give me is just a 2x to the third in the numerator. Everything else has a negative exponent, so we will be putting it down. So there already is a 2. There's an x squared and a y to the third, and we'll move everything else down. So we're going to move that y1, and then we've got 2 to the third. And as soon as we move them, they become positive. So there we go. Now that's everything. And you could have simplified this in your head as you went. That's no big deal, but those two will cancel out. And what will happen is, in this next step, we're going to kind of clean this up. We are going to have an x to the third up at the top, and I'm actually going to write them just one more time. If I add all the x's on the bottom, I'm going to get x to the 11th. And if I have that 2 to the third, that'll become 8. And then y, it looks like we'll just have 4. But since we have 3 of these x's on the top, or the numerator, got 11 down here, what you really have is 11 on the bottom. Now, the way that you look at this is if you did 3 minus 11, that is negative 8, but that negative 8 is in the numerator. So that numerator tells you that you have to put it in the denominator. Another way to look at it is that this is actually bottom heavy, so those guys are going to get absorbed by 3 of those in the denominator. So what you're left with is 1 over 8x to the 8th, y to the 4th. Okay, so next one. Cross those guys out. Those are all 1. Now, I'm not canceling it to 0. I'm canceling it to 1. Remember, this is all multiplication. Okay, multiplication and division. Great. If I put a plus sign, if I'm adding anything here, it totally changes the game. So everything has to be multiplied or exponentiated in order for you to do the things that we're doing here. Okay. All right, so with that, then it looks like we've got m to the 4th up at the top, and then we're going to move 3 n's down to the numerator. Okay, then it looks like 2 of those will cancel out here. We'll be left with 2 upstairs, so we got m to the 2nd, we got 2, and then we got n to the 3rd. This one right here, we're going to go ahead and distribute. I'm not going to have a lot of room here for sure, so I'm going to be real careful here. J is going to go to the negative 2nd. H will become a positive 2. K will become a positive 2. Okay. Then I'm going to actually add all of the H's together, add all of the J's, and add all of the K's together. And when I say add, I'm going to be adding their exponents. Really, I'm multiplying them, but because they have a similar base, I can add the exponents. So it looks like h to the negative 1 and h to the 1st power, those guys actually nullify themselves. So it looks like I actually have 4 h's in the denominator. J, okay, that's positive 2, negative 1, so that becomes a net of positive 1. Positive 1 plus this is j to the 5th. Okay, we took care of that. I'm going to cross them out just so I don't see them anymore. Then I've got, we already took care of h's, and we took care of that guy. So it looks like now for k's, I've got negative 3 plus 1 is negative 2, plus that is negative 4. Okay, so I've got one more step. Looks like the negative ones need to go up to the top. And the negative ones in the top need to go to the bottom. So I've got h squared, k2, k4. You could have added those in your head if you'd like. J squared comes down, h to the fourth stays, and that is j to the fifth, right? There we go. All right, so I'm a little concerned because, you know, I kind of lose track of this stuff too. I got to be careful. I'm just going to go down here. We got k to the sixth up at the top. Okay, and then those two get absorbed there, so we do have an h squared there, and then those j's actually add up to 7. So your final answer is this guy right there. So you could have danced a different way to get to this conclusion. So, you know, these are a little hard to teach, honestly. And they're a big source of confusion for lots of students over the years. It's pretty clear. You need a lot of practice with this stuff. All right, so we're raising everything to the third power. So what I could do is actually simplify everything in the middle and then raise everything to the third power. That's actually what I'm going to do to show you that there's alternate ways. Okay, so let's simplify here. I'm going to look at the numerator first. I got a 2, a to the negative 1, b to the fifth, c to the negative 1. Then I have a to the negative 4, c to the 8th. I'm distributing this 4 to here because it is multiplication, not addition. I can do that. And so just double checking here. 2 is good. B is, I see 5 of them, and C is just that guy. Okay, so we are good. Now remember, we are going to be raising this to 3, so we're going to keep reducing until we get it as low as we can go, and then we will actually distribute the 3. Okay, so next, they're all got a few wrong spots. Looks like these guys are going to rotate so that 2, a to the fourth goes to the numerator, a to the first goes down. When that happens, I'm going to have a net of 3 a's in the numerator. B is going to stay up there, and then C will actually go down. So now we're going to have 9 in there. Okay, now all of this is being raised to the third power. Okay, so next, oh yeah, okay, so here we go. Now we got 8, a to the 9th, b to the 15th, and c to the 27th. All right, so, you know, you could just leave that 3, wait till the end, simplify everything inside. That's a strategy. All right. So now what a log is an exponent. So we want to figure out what is the exponent that converts this base into that argument, okay? Or that power. I believe those are synonymous. But anyways, we're going to go ahead and think, okay, well, this is a fraction and he becomes a fraction. So there's no need to flip him or change his his position in the fraction. So he's going to stay exactly where he is. And so in order to change the 7 to 49, I would just need a 2. So 1/7 to the second power is 1 over 49. So that is the log. This guy right here, what I'm thinking is what exponent will actually give me negative 216? And if you've been scratching your head for a while, it's good reason, because you can't actually get a positive base to become a negative number. That's actually impossible. That's not what exponents do. So we would have to say that this is undefined. Okay, now in order to change a larger number, 81, to what? How am I going to get it to equal 3? So what power? Now I'm going to have to root this guy, okay? So I already have that. That is a root if it's an exponent, okay? So what I've got to do is think, all right, how does 81 get down to 3? Well, let's think of this backwards. What is the power that takes 3 to get to 81? And that is 4. So if you took the fourth root of 81, you're going in the backwards direction so that you can get to your 3. All right. So that is your final answer there. This is 4 becoming 64. Now, it does look like that this guy is not a fraction, so we need to turn him into a fraction. So the exponent must be negative. And we need 3 4s multiplied to each other to get to 64. So a negative 3. If you punch this into a calculator, you'd get 1 over 64, which is a decimal, and you don't know. You'd have to match and make sure that that is the decimal you're looking for. Okay, now I'm going to quickly do these. You're basically writing this in logarithmic form, so there's really no math to do. You just have to understand the structure. Okay, so you write down a log. These guys are all going to be logs. I don't see any e's, so it will just be logs. In fact, all of these are logs. Don't get used to that. You're definitely going to have a base e on the test. All right, so I have a base of 12, and I need to change it to 1/12. So what is the exponent? I have number 10. I have a log base 12 that needs to go to 144, and 2 is the exponent. Okay, the log base 7 needs to become 1 over 49, and that exponent is -2. And finally, the log base 5 to turn into 625 must equal 4. Go in the other direction. 13. Now here's where you want to do the loop. Okay, so 13 squared equals 169. You don't even, there's nothing to calculate. You're just showing its form. So again, you're not calculating anything. You already know what it is. Okay, 17 to the second power is 289. 6 to the third power is 216, and 1/10 to the third power equals 1 over 1,000. Okay, that's all it's asking. You're not going to have that many on your test. Okay, it's kind of redundant there. Where are we at on time? 11 minutes. We'll stop right there.